if you are defining a language where every word means something, you have to construct that meaning in your mind. You have to make a model in your mind that explains how that thing works. And if that particular thing that you're talking about in your language, a machine that is able to run for infinitely many steps in a finite amount of time, runs into contradictions, then that thing cannot exist. If you claim that it exists, you don't know what you're talking about. You have a contradiction in your own language because you cannot implement a meaning for that term. And implementing a meaning for that term means that the mathematical mind, the structure that is representing the interpretation for every term and so on, has no possible extension for that term into something that works. Right? You can talk about a square circle, but a square circle makes no sense. It's contradiction in terms. Right? You might even create a simulation in your own mind of a square circle, but it might even look interesting, but it's not actually a square circle. It's just an association that your mind is creating, an intuition of what that might be like. And so the switch from classical semantics in math to constructive semantics means that you are giving up on terms that intuitively make sense, like infinity, and replace it by unboundedness. And that means also that if you are describing physics with a certain type of mathematical language, then you should make sure that at the lowest level where you're trying to describe the foundations, you're not using terms that cannot be in physics. And this means that you cannot have processes that depend on knowing the last digit of pi, right? Because such a thing cannot be defined in such a way that it would make sense that reality would actually work like this. And this is not just the case for these low-level mathematical terms. When we are trying to structure our model of reality, it's important to not use terms that ultimately don't mean anything because we don't really know what they mean, that just create some kind of vague intuition in our mind. And when people talk about the basis of reality, when they use concepts like creation or God or universal vibration or energy, they often have superstitious terms, square circles, that they put at the root of their world model. They create some kind of association that seems to make sense to them, but it doesn't describe the kind of generator that their brain is using to produce their own model. So it's a very vague and inaccurate language. And I think that's not permissible.
The result of this constructivist turn of mathematics gives us a kind of a hard constraint on the limits of possible universes, because otherwise this universe would not be able to exist without having contradictions, and it would not be able would not be able to talk about it because it would not be kind of formalizable or describable in a language.
Yes, it gives us at least a limit on the languages that we can use to talk and think about universes. And when we cannot talk and think about them, then it doesn't make sense to conceptualize them, because we cannot actually conceptualize them without using superstitious terms that don't actually mean anything but being suggestive of something. There's a deeper question: what kind of limits does this pose on existence itself? Right, and then again, the question is, what does it mean to say that something exists? And if it wants to mean anything, that the terms of existence must be structured in such a way that they can be expressed in a language that makes any kind of sense. And ultimately, I think that existence comes down to whether it's implemented. And to be implemented, we can now talk about the space of things that can be implemented. And that seems to be coextensible with constructive math to me, or with some version of constructive mathematics. There might be additional constraints.
Yeah, I think this makes sense, but it would also mean that not all universes that we can or I don't know, not define, but maybe imagine, because we can say the word kind of a square circle, but we cannot. It has no real reference. But so in a way, there's an overhang of our imagination with relation to the possible universes that are realizable, or at least describable.
But the thing is, we cannot observe in our own mind a square circle. We cannot imagine it. What we can create is a representation that is the result of some kind of neural network that you entrain your brain with, and that is able to generate a circle or a square, right, to some approximation. and then you throw into this generator function the specification of a square circle, and it gives you a result. Right? And of course, this result is not going to be a square circle because it's impossible, but it's going to give you something. And this something can be described by some kind of function that is the result of that generator function that your brain implements. But it's not going to be a square circle. It's just going to be the thing that is generated by that specification by your particular brain. So understanding what that is, what could be something that oscillates between something that looks circular and something that looks squarish, and it goes back and forth between them, or it's something that when you zoom in looks one way and when you zoom out looks in a different way, or something that is three-dimensional, and from one perspective it looks like a square, from another one it looks like a circle, right? You can make all those things happen, but you're not going to get the actual square circle.